Regardless of the style of ultrasonic double sheet detector that you require, they all program identically. For that reason, now that we enter the mounting, alignment, and programming section, we're going to stick with the 18mm model as our example. Now it's time to take a look at mounting the emitter and the receiver. You can see them shown here in one of our optional U-shaped mounting brackets. The separation distance of the emitter and the receiver that's specified in each one of our product data sheets is very critical. For the 18mm UDC, the recommended separation is between 20 and 60 millimeters, with 45 millimeters being considered optimum. Beyond that, the alignment of the emitter and the receiver units, both center to center and the angular tilt, is very critical. The rear-mounted yellow LED, which you can see about the 11 o'clock position, is illuminated and lets you know when your alignment is perfect. I'm going to misalign the sensors for a short bit here, and you can see the LED blinks. And it'll blink faster the worse your alignment is, and slower once your alignment improves. Once the sensor is perfectly aligned, emitter and receiver, we can lock it down, and you're ready to look for some double sheets. Now let's discuss setting the programming modes. Each UDC model, whether it's the mini UDC through the 30mm UDC, has 4 individual program modes. Program 1 is the general setting, so it covers the broadest range of materials. Program 2 is specifically fine-tuned to detect materials on the thicker end of the spectrum. Program 3 is tuned to detect materials on the thinner end of the spectrum. And Program 4 is designed specifically to detect the very thinnest papers. Okay, so now we know how to mount and align the sensors, and we know which programs to select for the various media. So now it's time to configure one, lock in a program, and let the sensor do its job. There are 3 wires and 4 LEDs to facilitate setup. The supply and programming wires are brown, which is for positive supply, blue for negative supply, and pink, which allows you to toggle through the 4 programs, and also, in the operational mode, provide 120 millisecond pulse extension. Programming step 1. Connect the brown and blue to positive and negative supply, but leave the pink wire unconnected. You'll notice a green blinking LED at the 2 o'clock position. The blink count corresponds to the programming mode 1 through 4. Here we see a single blink. If the blink count corresponds to the program you want to utilize, well, your work's done. Simply attach the pink wire to the plus supply if you want a 120 millisecond pulse lengthening feature, or the negative supply if you don't require that function. Your sensor's ready for operation. If the program number does not meet your needs, then simply touch the pink wire to negative supply twice to enter the programming mode. Next, touch the pink wire to the positive supply. The blinking LED will increment its count to the next program number. Now you can see program 2, program 3, and program 4. Once the desired programming number is reached, touch the pink wire to the negative supply to lock it into memory. The green LED will cease blinking, and the LED at the 11 o'clock position will illuminate constantly. This signals that there's no sheet present. As we can see, there is no sheet present. If you keep the pink wire attached to the negative, the sensor output will respond immediately to any 0, single, or double sheet occurrence. If you attach the pink wire to the positive, the sensor adds its 120 millisecond off delay to all 3 outputs. Connect your output wires, gray for 0 sheet, white for single sheet, and black for double sheet, to your controller, and you're ready to go. Now that we've discussed the mounting, alignment, and programming of the units, it's time to see how they respond when presented with different materials. In front of me I have 2 different models. The UDC 400 series is designed to detect materials on the lighter end of the spectrum. The UDC 255 series is designed to detect heavier weight materials. Now let's take a look and see how they respond when presented with the same material. Here we have a single sheet of office paper. Single sheet, double sheet. No problem, very reliable. If we go to the stronger unit, single sheet, and it still thinks there's a single sheet there. It's so powerful it burns through the paper. Now let's take a look at something a little bit thicker, business cards. Again, the 400 series, single sheet, double sheet, very reliable. And we come over here, single sheet again. It can't distinguish the difference. Now let's move up in heaviness a little bit. Now we have a thicker piece of plastic. You can see the 400 series identifies it immediately as a double sheet. It doesn't have the power to burn through it. If we go here, we see that the 255 series, no problem, detects the thicker plastics as a double sheet. The last one we want to take a look at is a little semi-thick piece of cardboard. Again, the 400 series views that as a double sheet. It doesn't have the power. The unit here, the 255 series, single sheet, double sheet, but it's a little flaky. You can see here it burns through it. You have to remember, when you use thicker materials, you need to angle them. So we say in our data sheets a 35-degree angle is recommended. That's what you want to do if you have thicker plastics or some different types of cardboards. For more information on ultrasonic double sheet detectors, you can visit the ultrasonic section of our website. If you have an application for them, give one of our application engineers a call to discuss it, or send in a sample and we'll be happy to evaluate it. Thanks for your time in viewing our video, and I hope you found it helpful.